Hey, my nuggets, it's Miss Logan. I'm going to be talking to you about perimeter today. So at the top of your notebook paper, I'm going to have you write that down. And today we're going to be focusing in our book on pages 268 to 272. So the first thing that we want to talk about when it comes to perimeter is we want to know what the definition of perimeter is. So on my paper, I'm going to write the definition down. And the definition to perimeter is the distance around a polygon. Now, when we talk about distance, there's a couple of different units that we use to talk about that particular word. And the word that you're going to hear the most often is you're going to hear the word length. So when we talk about the word length, it means two things. Now, of course, we talk about it and we say length. That means how long something is, right? I'm going to fix that spelling there. The length, that means how long something is. And then we also say that there is a width, how wide something is. So something that's important to remember is when we talk about this word here, length, is that it kind of means two different things. We're talking about the length and we're talking about the width, which are two very important things when we talk about perimeter or the distance around a polygon. I'm going to go ahead and erase these and then continue our conversation towards the top of our paper. So when we talk about the length and width of a shape, I just want to give you a quick example of that. So I'm going to draw a polygon or a quadrilateral on my notebook paper. And now I'm going to erase this bottom half because I believe that we should have had enough time to write that down. So I have got a polygon here on my paper. And when we talk about how long something is or the length, that would mean this side of your shape. So it's either this side or this side when we talk about the length. And when we talk about width, we're talking about the opposite sides. This is how wide something is. And then we're also talking about that side over here. So we want to find out what is the perimeter of this shape. Okay, so when we talk about finding the perimeter of a shape, we want to know the width and we want to know the length of that shape. If we know at least, particularly when it comes to one of these rectangles here, we need to know the length of at least two of the sides to figure it out. So in your book, on example 1 on page 268, you guys will see that it gives you the width for one side and the length for one side. So I'm going to go ahead and mark those in on my paper. And they gave us the width as 2 centimeters. That's our unit there. And then they gave us our length as 3 centimeters. So I've got my width over here, 2 centimeters, and my length over here, 3 centimeters. So there is a particular formula that we are going to be talking about when we talk about perimeter. And that formula, the first formula, is actually going to be P equals, and this P here stands for perimeter, length plus width plus width. And when we talk about a quadrilateral, that's this shape, which is also a polygon in this case, we agreed that quadrilaterals have sides that are parallel to each other. You guys may remember that from about 2 weeks ago when we talked about parallel. And when we talk about parallel, the definition of parallel or parallel lines is that the lines are an equal distance from each other, but also that they will never intersect or cross over with one another, right? So in this case, our rectangle has these two lines that run parallel to each other, but also these two lines that run parallel to each other. You'll have to excuse me. I'm outside, so there's a nice airplane flying over my building right now. But we're going back to talking about these parallel lines. I have two sides here, this side and this side, that are my lengths. That's why I wrote two L's. And then I have this side here and this side here, which are my W's. Now, if I know the length of this side, I know that because these two lines are parallel, that means that this line and this line have the same measurement for its length. So this side up here is also 3 centimeters. And then the same with these opposing lines or opposite lines. This width we decided was 2 centimeters. So I know on this side, this particular line is 2 centimeters as well, because they are parallel to each other, which means they are an equal distance in length, right? So I've got two L's, my length here, and then I got two W's. I can fill that into my equation and then add them together to get my perimeter. So here's what I'm going to do. I'm actually going to go ahead and erase my shape because I want to leave the formula down below. And I want to show you what I mean here. So we decided that our length was equal to 3 centimeters and our width was equal to 2 centimeters, right? Now there are 4 sides to that shape that I drew. It's a little shape like so. We'll do our 3 centimeters down here and then our 2 centimeters off to the side. Just a little mini diagram for you guys. How we want to fill in that equation is we want to say P equals, okay, our lengths are 3. So I've got 3 here, and then 2 here, and 2 here. So I've got to put my 2 3's in, 3 plus 3, and then these sides are 2, so I'm going to put 2 plus 2. Now I've got to add them together. I know that 3 plus 3 plus 2 plus 2 is ultimately going to give me 10 centimeters. That is the perimeter of the shape for example 1 in your book. All right, so we are actually going to give you another formula. We did the addition version here, but we're going to give you another formula for perimeter. And a quick way to do it as well is to do multiplication, right? So I have my shape. I'm going to draw that again, and it's 3 centimeters over here, 2 centimeters over here, 2 centimeters over here, and then 3 centimeters here. All right, so I've got my sides here. And I know that there are 2 sides equal to 2 centimeters and 2 sides equal to 3 centimeters. So I'm still going to have my P because P stands for perimeter, right? But since I have 2 sides and 2 sides here, I know that I'm going to use a 2 to multiply by my length because there's 2 sides that stand for the length. And then I'm going to add it to my 2 sides that are my width. So I've got 2 sides that are my width. So I've got 2 times L, 2 times W, and I add those together and it gives me my P. Now, when we have a letter, or we call this a variable in math, and a number or coefficient in math, and they're stuck together like that, we do the operation multiplication in math. So we're actually going to plug our numbers into our equation here and see what we get. Now our last equation got us 10 centimeters. That's what P equaled in our last formula. So we're going to plug our numbers in here and see if we get the same thing. So P equals 2, well, I know my length is 3 centimeters. So I'm going to put 2 times 3, and then I have my plus in the middle. And then I have my 2 widths. One of them is 2, so I'm going to multiply that by 2. All right, so 2 times 3 is going to get me 6, and then, so I'm going to write my plus here. And then 2 times 2 is going to give me 4. Well, 6 plus 4 is going to give me 10 centimeters. So even though we multiplied this time, we've still got the same answer. I'm going to go ahead and erase that and show you one more thing for today. All right, so we've got to talk about polygons, and polygons can be four-sided shapes, but sometimes they're shaped like other things. So on example E, or section E in your book, you guys will see that there are a number of different types of polygons. We have triangles. Triangles have three sides. We can have a regular polygon like a square or a rectangle. That's what we just did. We can have something like another regular polygon. Maybe it has 5 sides, or maybe it has 6 sides like a hexagon. It could be an octagon. Maybe it has 8 sides to it. Right? So one of the things that we have to consider when we do our formula is that not all figures are going to have 2 equal sides. Some may have 3. So if I want to know the distance of a triangle, this particular triangle looks like an isosceles triangle, which means, oh, I'm so sorry, it looks like an equilateral triangle. So all 3 sides would be equal to each other, right? So what I want to do to find the distance around is I can take 3 and multiply it times one of the lengths of the side. If I said this one was 4 centimeters, then they were all equal to each other. I'd do 3 times 4, which would give me 12 centimeters. That would be the perimeter of my triangle. The point that I'm trying to make is that we can't always do the equation like a square. Sometimes we have to consider that different shapes have many more sides to them. Alrighty, last concept for today is circles. Now, a circle is a very interesting shape because it technically has no sides. The definition of circle is that it is a smooth curve. Meaning that it's not quite your average quadrilateral or polygon. So we've got a lot more to consider when we talk about the perimeter of a circle. Now, when we say perimeter of a circle, we're meaning the distance around a circle. We also call that in math circumference. We can say perimeter of a circle, or we can say circumference. These two words here are actually interchangeable with each other. They mean the same thing, but we think about it a little bit differently when we're talking about a circle. So in order to know the perimeter or the circumference or the distance around a circle, what we need to do is we need to know a couple of different parts of the circle, and we'll expand upon that later. But right now I want to identify several parts of a circle. So this little middle point, the very center of a circle, is known as the middle point. That is the very center of a circle. It's called the middle point. Now, the distance from this center point to the edge of the curve is actually called the radius. The distance from the center point or the middle point of the circle all the way out to the curve is called the radius. And if we were to go right through this point from curve to curve, like so, we would actually call this long line here the diameter. That's an M here, in case you're wondering. We would call it the diameter. I'll go ahead and write it up here. And when you think about it, if you took 2 radii, or radius, and put them together, that would equal a diameter, because the diameter is the distance from one curve of the circle all the way through the middle point to the other side of the curve, whereas the radius just goes from the middle point to one curve of the circle. Be sure to submit your notes for this lesson and attach a photo to your assignment. We will be talking about this more in the days to come. Bye, guys.